Why shouldn't metal objects be placed inside microwave ovens?
Manufacturers caution consumers about placing metal containers and aluminium foil inside microwave ovens for two main reasons. The first reason is that metal and aluminium may impede cooking. Microwaves warm food by transmitting energy to water and fat molecules within the food. If food is placed under aluminium foil or in a metal container, the microwaves will be reflected from the metal and won't be able to reach the water molecules and cook the food. The second reason for not placing metal objects inside a microwave oven is for the safety of the microwave oven itself. Metal acts as a mirror to microwaves. If too much metal is placed in the oven, the microwaves will bounce around the oven in waves that can damage the magnetron that produces the microwaves. If the metal is the correct size, it can act as a microwave receiver, and the induced voltages can produce sparks that can ignite the food.
What is a white light?
The combination of all the colors in the visible spectrum.
What happens if your car is on ice?
Often then the friction between the tires and the ice is so small that the wheels can't exert enough backward force on the ice for the ice to exert the force needed to accelerate the car. Note that friction, instead of being a bad thing, as suggested earlier, is needed in this case.
Are there anti-quarks like there are antineutrinos and anti-electrons, positrons?
Yes, there are anti-up quarks with charge -2/3 and anti-down quarks with charge 1/3. An antiproton is composed of two anti-up and one anti-down quarks. Antiquarks have color charges that are the complementary colors to red, green, and blue, cyan, anti-red, magenta, anti-green, and yellow, anti-blue. An up, or down, quark and an anti-up, or anti-down quark will annihilate each other, resulting in energy being released.
What happens if the two forces are in opposite directions? What happens if both forces are equal? If one is stronger than the other?
If they are both equal, the car will remain motionless. That is, it will act as if there is no force on it. If one is stronger than the other, then it will move in the direction of the smaller force, but it will accelerate less. That is, the results will be the difference between the two forces. We'll explore forces that act in different directions later. Physicists say that the combination, addition, or subtraction of forces produces a net force, and it is the net force that affects the acceleration. Thus Newton's laws should be written as follows. Newton's first law: if there is no net force on an object, then if it was at rest it will remain at rest. If it was moving, it will continue to move at the same speed and in the same direction. Newton's second law: if a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnet/m. Or, Fnet equals ma. Couch is heavier, the opposing force will be larger. The amount of force opposing you will depend on the surface the couch is on. A carpet will have a stronger opposing force than a smooth surface, like wood or tile. These observations summarize the properties of friction between two objects that are in contact. Friction is always in the direction opposite the motion. Friction is greater if the moving object is heavier. Friction is greater if the surface is rougher. But, friction does not increase if the speed of motion increases.
What is the origin of the masses of the quarks and leptons?
Peter Higgs, 1929, a British physicist, proposed a mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z. The mechanism successfully predicted the mass of the Z boson. But it requires the existence of a particle, called the Higgs boson. Despite many searches, the Higgs boson has not yet been discovered. Physicists hope that the Large Hadron Collider, LHC, that started operation in 2010 will accelerate protons to high enough energies that the Higgs will be found.
What are microwaves?
Electromagnetic waves with frequencies above about 3 GHz.
Why are broadcast frequencies so limited?
Suppose the analog signal is a 440 Hz tone, the A above middle C on a piano. A typical AM transmitter would have a carrier wave frequency of 1 MHz, megahertz. The result is a signal with three different frequencies, 1 MHz, 1 MHz plus 440 Hz and 1 MHz, 440 Hz. Thus the total signal requires a set of frequencies 880 Hz wide. Sounds with a frequency of 4 kHz require a range of frequencies called the bandwidth, 8 kHz wide, just about the spacing between adjacent stations. FM stations, on the other hand, were developed to transmit sounds more faithfully, which means that sounds up to 15 kHz must be accommodated. That means that the bandwidth of the broadcasts is 30 kHz wide. At the very high frequencies used by FM stations there is more bandwidth available and stations are spaced by 200 kHz. The electromagnetic spectrum has many other users. Police and firefighters usually use AM, while aircraft, where noise reduction is important, use FM. Television stations used to use AM for the picture and FM for the sound. But as of June 12, 2009, they now all use digital signals. Other users are the military, marine ship-to-shore services, weather broadcasts, commercial mobile phones, the citizen band, and amateur radio operators. They all share the HF, VHF, UHF, and SHF bands.
Why is a wedge like an inclined plane?
A knife is one example of a wedge. Look carefully at the sharp edge of a kitchen knife. It looks like two inclined planes put back to back. As the knife blade moves down through food, the wedge pushes the pieces apart. A hatchet or axe is another example of a wedge. Wedges are also used to split wood. In this case, the flat end of an axe is often used to drive the wedge into the end of a log, which is then forced apart. Wedges are inefficient machines because there is usually a large amount of friction between the wedge and the material, which leads to increased temperature of both the material and wedge, and thus heat transfer.
What is work?
Energy transfer by mechanical means.
What is a spectrum and what are continuous and line spectra?
Newton showed that when white light is passed through a prism, it is split into a spectrum of all colors from violet through red. There were no gaps between the colors, so the spectrum is called continuous. The emission line of sodium has only 2 yellow lines. Hydrogen has 4 lines. The spectrum of iron, on the other hand, has an extremely large number of lines. An absorption line spectrum occurs when the low-density gas absorbs distinct colors, leaving dark gaps in the otherwise continuous spectrum. For example, the spectrum that the German physicist Joseph von Fraunhofer (1787–1826) took of the spectrum of the Sun in 1814 showed 574 dark lines. In 1859 they were explained as being absorption lines from the cooler gases in the Sun's atmosphere. Fraunhofer made the best optical glass of any glassmaker of his era. He made great improvements to the achromatic lens, which refracts light of all colors the same amount. Like most glassmakers of his era, he died young. most likely from the poisonous effects of the materials used to make the glass.
What is a candela, CD?
Unit of measurement of luminous intensity.
How do you convert from one scale to another?
Use the conversion chart below to convert between Celsius, Fahrenheit, and Kelvin. From to formula Celsius Kelvin degree C equals K plus 273.
What is the difference between hue and saturation?
Hue is related to the wavelength of a color. Saturation is the extent to which other wavelengths of light are present in a particular color. For example, for the hue red, deep red is saturated, but pink is a mixture of red and white.
How is surfing a lot like downhill skiing? How can they be similar?
Surfing is done on water, skiing on snow. The main similarity is that in both cases the athlete and board travel down a hill. In skiing, the hill is a mountain covered with snow. While in surfing the hill is the rising water of a breaking ocean wave. An ideal surfing wave has a large amplitude as it reaches an extremely gradual decrease in ocean depth. While the surfer moves down the wave, the water on the front edge of a crest continually rises underneath the surfer, allowing the surfer to ride down the wave without actually moving downward. Some of the best surfing is done on Waikiki Beach on Oahu in the summer and the north shores of Oahu and Kauai in Hawaii in the winter. In the continental United States, the best surfing is in Southern California. The Pacific Ocean, famous for its long wavelengths and gradual decreasing depth beaches, has some of the best surfing in the world.
What is a physics education research?
Study of how people learn physics and how best to teach them.
What is a first-class lever?
Simple machine with pivot at one end or bar. The input force applied at the other end, the effort force between the two. Ma greater than 1.
Why don't birds or squirrels on power lines get electrocuted?
In order to get electrocuted on a bare wire, a bird would have to be in contact with objects that had two different voltages. The difference in voltage along the wire over the distance between the animal's feet is very small. The animal would be in danger only if it made contact with both a high voltage wire and the ground, or a wire connected to ground, low voltage. Then there could be a large current through its body.
What is a high-frequency, HF, wave?
Frequency 3 MHz 30 MHz.
How can the emission and absorption of light by atoms be explained?
In 1911, Niels Bohr, 1885 to 1962, a Dane who recently had received his Ph.D. from the University of Copenhagen, joined Rutherford at Cambridge University. He quickly began work on the Rutherford model. He published his results in 1913, basing them on three postulates. 1. Electrons only move in certain allowed orbits at discrete radii and with specific energies. That is, their radii and energies are quantized. When in these orbits their radii and energies are constant, the atoms do not emit or absorb radiation. 2. Electrons gain or lose energy when they jump from one allowed orbit to another. Then they emit or absorb light with a frequency given by HF equals E2, EI, where E2 and EI are the energies of the electrons in the allowed orbits. The constant H is called Planck's constant, 6.6 x 10 to 34 J/Hz, joules per Hertz. 3. The correspondence principle. When the electron is very far away from the nucleus, classical physics must give the same answer as the new quantum physics. He later changed the third postulate from the correspondence principle to requiring that the angular momentum of the electron be quantized, that is proportional to an integer called the quantum number. The results didn't change, but the derivation of them was more straightforward. This method is presented in almost every textbook. The two drawings below illustrate the emission of light when the electron goes from a higher energy to a lower energy orbit, and the absorption of light when the electron's energy is increased. In 1885, Johann Balmer had found a formula that accurately calculated the wavelengths of the visible hydrogen spectrum. It was purely empirical, that is, there was no physics-based explanation of it. In 1888, Jan Rydberg generalized Balmer's results to allow calculation of hydrogen emission in the ultraviolet and infrared. Bohr was able to explain Balmer's and Rydberg's formulae using the results of his postulates. The equation for the wavelength of the emitted radiation is 1/x equals r, I/m2, 1/n2. The numbers m and n are the quantum numbers of the two energy levels. For example, the red line would have m equals 2, n equals 3. The constant r is 0.01097 nm1, making the wavelength of the red line 1/0.01097, V4, 1/9, nm1, equals 656.3 nanometers, in excellent agreement with the experiment. Thus Bohr's model is a major advance in understanding the structure of the atom.
What is a Faraday cage?
A Faraday cage, named after British physicist Michael Faraday, is a cage. Metal grating, or metallic box that can shield electrical charge. Charges gather on the outer shell of the cage because they are repelled by one another and can be further from each other if they are on the outside of the cage. This results in no charge within the Faraday cage. The metal sphere of a Van de Graaff generator is a Faraday cage. Cars and airplanes can be Faraday cages as well, and may provide some protection from lightning during an electrical storm.
How is it explained using quarks?
Beta-decay involves two steps. First, the down quark changes to an up quark with the emission of a W boson. Then, almost instantaneously the W changes into an electron and antineutrino. Physicist's diagram. The two beta-decay processes this way. When a nucleus undergoes beta-decay, the number of neutrons goes down by 1. The number of protons goes up by 1, and an electron and antineutrino are emitted. In terms of quarks and leptons, one of the down quarks in the neutron is changed to an up quark in the proton. And a lepton, electron, and antilepton, antineutrino, are emitted. The change from down to up quark is a flavor change, and that can occur only in beta decay. When a positron is emitted in inverse beta decay, an up quark in the proton is changed to a down quark in the neutrino, and a lepton, neutrino, and antilepton, positron, are emitted.
What is meant by a law as opposed to a theory?
Laws summarize observations. They describe phenomena. A theory explains a large number of observations. Einstein's theory of gravity explains Newton's law of gravitation, which can be used to derive Kepler's three laws. A theory cannot become a law because they are essentially different things.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
What does energy efficiency mean?
In most cases, thermal energy is not a useful form of energy for a system. You want the energy content in the gasoline in your auto to give it kinetic energy, not to make it hotter. The cooling system uses a water antifreeze mixture to cool the engine and warm the radiator. Where air flowing through it is heated, thus cooling the fluid. The thermal energy in the heated air is often called rejected or waste energy. An auto is about 20% efficient. That is, only 1/5 of the energy in the gasoline is converted into the kinetic energy of the auto. In addition to the hot air from the engine, tires get warm from flexing. And the brakes get hot when they are applied. All this thermal energy is rejected or waste energy. Your home furnace converts the chemical energy in oil or gas or electrical energy into thermal energy, either of air or water, depending on whether you have forced air heat or hot water radiators. But not all the energy goes into heating the house. Some leaves through the chimney as rejected or waste energy. Heating systems used to be about 60% efficient. Newer systems can be as much as 95% efficient. Means of increasing the efficiency of auto and home appliances is an active area of research as nations try to conserve as much of the produced energy as they can. Your body also uses only a fraction, again about 20%, of the food energy to move your limbs when you walk or run. Your body is cooled by contact with the air, or by evaporating liquid, either perspiration or the humid air expelled by your lungs.
Can a microwave oven be used to dry things?
Since water molecules are warmed and eventually boil off by microwaves, anything that is wet can be dried in the microwave. However, there is one very important consideration that must be made before placing the object inside a microwave. The object being dried must not contain a great deal of water itself. Microwaves are wonderful at drying wet books, papers, and magazines, but must never be used to dry things like plants or small animals. Living things would be killed by the resonance of water molecules inside their bodies.
How can you describe the path of a thrown ball?
You know what happens when a ball is dropped. It accelerates downward, gaining speed at a rate of 9.8 m/s each second.
What is the relationship between current, voltage, and resistance?
Voltage equals current x resistance, or V equals IR. That is, the voltage difference across a resistor is equal to the current through it multiplied by its resistance.
What is a sonar?
Acronym for Sound Navigation and Ranging. A method of using sound waves to determine the distance between an object and a sound transmitter.
What are elementary particles?
Study of the interactions and properties of the particles from which all matter is built.
What is a light year?
A year is a unit of time, but a light year is a unit of distance. Specifically, it is the distance that light travels in 1 year. Since light travels at 299,792 km per second and a year consists of 31.557 x 106 s. A light year is 9.4605 x 1012 km or about 6 trillion miles. The light year is used to express distances to stars and galaxies.
But how are they combined?
You can't simply add them, because they have different directions. Go back to the drawing with the arrow. Define north as the direction toward the top of the page. Then add a second arrow 2.0 long in the upward direction. The tails of the two arrows are at the same place, representing the intersection of Main Street and First Avenue. The two arrows are half of a rectangle 1.6 wide and 2.0 high. Draw lines completing the rectangle. The location of the house would be at the upper right-hand corner of the rectangle. Draw a third arrow, with the tail at the intersection of the other two vectors and the heat at the upper right-hand corner. The length of the arrow can be measured on your drawing, or calculated using the Pythagorean Theorem, the square of the length, the hypotenuse of a right triangle, is equal to the sum of the squares of the other two sides. In this case, 1.62 plus 2.02 equals 6.56. Then length is the square root of that, or 2.56. So in real life the displacement would have a magnitude of 256 feet.
What is a plasma physics?
Study of the properties of large numbers of electrically charged atoms.
When was it thought that there were different kinds of electricity?
As you have seen, Benjamin Franklin's kite experiment showed that lightning and static electricity were the same. Since ancient times humans knew that certain fish, such as the electric eel, could shock a person.
Is it true that lightning never strikes the same place twice?
This is absolutely false. The Empire State Building in New York City is just one example of where lightning has struck more than once. In some thunderstorms, the tower on the Empire State Building has been hit several dozen times.
What is a sublimation?
Change of state from solid directly to gas.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
What is a superposition?
Two or more waves at the same location pass through each other without interaction. The amplitudes of the two waves add or subtract.
What is latent heat?
Energy needed to change phase of matter.
How can you check to make sure a pair of sunglasses is polarized?
Polarized lenses are transparent only to light that has its electric field oriented in one direction. Therefore, if a pair of sunglasses is polarized, two pairs of the same sunglasses, when aligned perpendicular to each other, should not allow any light to pass through the lenses. Light from the sky is also partially polarized due to the scattering of light off gas molecules in the atmosphere. So if you put on a pair of polarized sunglasses and tilt your head so that your ear were near your shoulder, you should see a change in the intensity of the sky on a clear, sunny day. If you see no such change, then the sunglasses are not polarized.
What is a polarized wave?
Transverse wave, like light, with amplitude in one direction.
What is power, P?
The change in energy divided by the time taken.
What is a thermograph?
Picture that shows the temperature of every location in the picture. Thermometer device to measure temperature.
What is quantum mechanics?
Study of atoms by themselves, as well as in molecules, liquids, and solids in which the wave nature is important.
What is the name of the supporting force from the chair?
Another term for a supporting force is normal force. The normal force is always directed perpendicularly out of the surface. The normal force of a chair is straight up if the chair is on a level surface, while the normal force of an incline would be perpendicular to the surface of the incline, and not perfectly vertical. The term normal was derived from the geometrical name for a 90 degrees angle and is not the opposite of abnormal.
What is work?
Energy transfer by mechanical means.
What is graviton?
Particle that carries the gravitational force.
How did resonance destroy the Tacoma Narrows Bridge in Washington State?
The Tacoma Narrows Bridge, or Galloping Gertie as it was often called, was built in 1940 and was known for its unusual, undulating movement. All bridges vibrate to some extent, but to many motorists, the suspension bridge in Tacoma felt more like an amusement park ride than a bridge. On the morning of November 7, 1940, 4 months after the bridge opened, the wind was blowing at approximately 42 miles per hour. This moderate wind hit the solid bridge deck and caused the deck to vibrate back and forth as it did almost every day since the bridge had opened. But the bridge began to vibrate more dramatically than ever before. It appeared as though a standing wave had formed between the two towers of the bridge. There was one distinct node in the center of the bridge and an antinode on each side of the node. After several hours of dramatic vibrations, the bridge deck collapsed into the river below. Along with its only casualty, a dog named Tubby, left in a car by its owner, who narrowly escaped death himself. There is still an active controversy about the exact cause of the collapse of the bridge.
What is the difference between speed and velocity?
Just as you can add direction to a change in position and end up with displacement, you can also specify the direction of motion. The combination of speed with direction is called velocity. Velocity is the displacement divided by the time required to make the change, or the time rate of change of displacement. Velocity is a vector quantity, like displacement. You might walk at 4 miles per hour north, or a balloon might move at 5 feet per second up. If you assign the variable x to represent north/south, y to east/west, and z to up/down position, then both the change in position and speed would be positive for movement to the north, east, or up. Your walking velocity would be plus 4x mph. The balloon's would be plus 5z. Foot/s average speed is almost always more useful than average velocity. For example, in a NASCAR race the starting and finish lines are in the same position. So, no matter how fast the cars go, their average velocity is 0 because the beginning and ending positions are the same. Instantaneous velocity, however, is more useful than instantaneous speed, as will be shown shortly.
How does an airplane wing create lift?
The upward force on an airplane wing caused by the air moving past it is called lift. According to Newton's third law, if the air exerts an upward force on the wing, then the wing must exert a downward force on the air. There are 3 causes of this downward force. The first is the tilt, or angle of attack of the wing. The tilt deflects the airflow downward. The second is the Bernoulli principle. Because of the shape of the wing, the speed of the air on the top surface of the wing is faster than at the lower surface, and so the pressure is lower. Thus the downward force on the wing is reduced. The third reason is the fact that air sticks to the surface of the wing. The air coming off the upper surface is moving downward. This exerts an additional downward force on the air. The downward forces produce the lift needed to keep the plane airborne.
What is speed?
If something moves from position to position, then speed is a measure of how fast it moved. Speed is defined as the distance moved divided by the time needed to move. Both change in position or distance and time are measured quantities. Frequently, speed is called the time rate of change of distance. For example, if you drive 240 miles in 4 hours, then your speed is 60 miles per hour, abbreviated mph. It is unlikely that you drove the whole trip at a constant 60 miles per hour. This example calculated your average speed. If you were pulled over for speeding and were told you were going 80 miles per hour, you wouldn't be able to avoid a ticket by saying, "But officer, my average speed is only 60. The vertical lines you see on a map or globe are lines of longitude and the horizontal lines are lines of latitude.
What is a noise?
Sound intensity at a wide variety of different wavelengths.
How does accuracy differ from precision?
Both accuracy and precision are often used interchangeably in everyday conversation. However, each has a unique meaning. Accuracy defines how correct or how close to the accepted result or standard a measurement or calculation has been. Precision describes how well the results can be reproduced. For example, a person who can repeatedly hit a bull's-eye with a bow and arrow is accurate and precise. If the person's arrows all fall within a small region away from the bull's-eye, then she or he is precise, but not accurate. If the person's arrows are scattered all over the target and the ground behind it, the she or he is neither precise nor accurate.
Why aren't the Van Allen belts present around the North and South poles?
At the equator, the magnetic field is parallel to the ground and the electrons and protons from the solar wind can become trapped around the field lines. At the poles, however, the magnetic field strengthens, the lines become closer together, and forces on the particles push them back toward the equator. Some of the most energetic particles are able to penetrate the atmosphere where they interact with oxygen and nitrogen atoms, producing the natural light shows that are called auroras.
What nuclear force is responsible for beta-decay?
The weak nuclear force is the cause of beta-decay. It is 10 to 13, 1/10 trillionth, as strong as the strong force. As a result, the half-life of most beta-decaying nuclei is long. In 1968, Abdus Salam, Sheldon Glashow, and Steven Weinberg showed that the electromagnetic force and the weak nuclear force were actually different aspects of a single force, the electroweak force.
Who developed the ideas of conservation of momentum and conservation of energy?
Isaac Newton, 1642 to 1727, considering collisions. First described momentum as the product of mass and velocity, but he called it the quantity of motion. Energy took 150 years from the first statement of principles until the terminology was worked out. Collisions also inspired the Dutch physicist Christian Huygens, 1629 to 1695, who wrote that in the collision of two perfectly elastic spheres the sum of what we today call kinetic energy would not be changed by the collision. The German scientist Gottfried Wilhelm Leibniz, 1646 to 1716, gave the name vis viva in 1695 to kinetic energy. But how could the conservation of vis viva be extended beyond elastic collisions? Finding the answer to this question took over 150 years. An important contribution was made by Benjamin Thompson, 1753 to 1814. Thompson was born in Massachusetts, but because he opposed the American Revolution he left for England and was knighted by King George III and given the title Count Rumford. While in America he spied for the British. While in England he spied for the French and was a counter-spy for the British. He moved to Bavaria, now part of Germany, and became Minister of War, among other duties. Because he ran an orphanage and wanted to save money, he studied heat and invented many items, like an efficient stove and a coffee percolator. A long series of experiments led him to conclude in 1798 that thermal energy was nothing more than the vibratory motion of what we know today as the atoms that make up the material. About 20 years before Rumford's work, the French scientists Antoine Laurent de Lavoisier, 1743 to 1794, and Pierre-Simon Laplace, 1749 to 1827, showed that heat produced by a guinea pig after eating was very close to the heat produced when the food was burned. The development of steam engines by James Watt and others stimulated studies of the relationship between work done and heat produced and how to make engines more efficient. Around 1807 the word energy was used with its modern meaning. In 1842 a German physician, Julius Robert von Meyer, 1814 to 1878, proposed that all forms of energy are equivalent and that the sum of all forms is conserved. He wrote in general, qualitative terms. Although in later essays he included quantitative evidence based on the work done when a gas was heated. But his work resulted in little recognition until the end of his life. About the same time, a British amateur of science, James Prescott Joule, 1818 to 1889, began a series of experiments designed to determine the relationship between work done and thermal energy increase that resulted in heat transmitted to the outside. He explored electric generators, the compression of gases, and stirring water. His experiments lasted 18 years. As he continued to publish his results, they were taken more and more seriously. The German physicist and physiologist Hermann von Helmholtz, 1821 to 1894, developed a mathematical description published in 1847 that showed precisely how energy was conserved in many fields including mechanics, thermal energy and heat, electricity and magnetism, chemistry, and astronomy. With his results, the scientific community recognized the great achievement of Rumford, Meyer, Joule, and others and fully accepted energy conservation.
What is neutrino oscillation?
Change of neutrinos from one flavor to another, that is a proposed solution to deficit of neutrinos emitted by Sun.
What is a convex mirror?
Curved outward. The reflected light spreads out rather than converging at a point.
What is energy?
An object with energy can change itself or its environment. That's a pretty abstract definition. Let's explore some of the many ways an object can have energy and what changes it can cause. A speeding car has energy. Think what damage it can do if it hits a wall or another car. The energy of motion is called kinetic energy. A rotating wheel also has energy. If you try to stop a spinning bicycle wheel with your hand, it may hurt you. This kind of energy is called rotational kinetic energy. A compressed spring or a stretched rubber band can cause a stone to move. The energy in the squeezed spring or stretched band is called elastic energy. There are a variety of other forms of energy that are stored in a material. The random motion of the atoms that make up the material means that the atoms have kinetic energy. A measure of the amount of the kinetic energy in the random motion of the atoms is called temperature. The more energy, the higher the temperature. Kinetic energy in the random motion of atoms in a material is called thermal energy. If you charge or discharge a battery, like the one in your cell phone, you change the chemical composition of the battery materials. When you charge it, you increase its chemical energy. You can also increase the chemical energy of your body by eating. Even mass has stored energy. Splitting the nucleus of a uranium atom results in elements that have smaller mass but a large amount of kinetic energy.
What is a wedge?
Simple machine used to force two objects apart. Examples are the knife, hatchet, or axe, and plow.
Does velocity affect distance and time?
Einstein's special theory of relativity shows that both distance and time change with velocity. Einstein reached this conclusion by noting that one must define methods of measuring both distance and time. The result is that as objects move near the speed of light, their length in the direction of motion shrinks, and their internal clocks that measure time run slower. The amount of change is described by a factor called y, gamma, which is always larger than 1. Thus the time given by a moving clock is yt, where t is the time shown by a fixed clock. And length is given by Li, where L is the length of the fixed object.
What are the different frequencies of radio waves and microwaves that allow for communication?
The table below shows the regions of the electromagnetic spectrum and their uses. The unit for frequency is Hertz, Hertz. Hertz is the name for the number of oscillations or cycles per second of a wave. The letters kilohertz mean 1000 Hertz. Megahertz a million Hertz, and GHz 1000 million or a billion Hertz or cycles per second.
How much extra energy is needed to heat the pan?
The answer is found by multiplying the specific heat capacity of aluminium, 897 J/kg degree C, by the mass, 0.3 kilograms, and by the temperature change, 80 degrees Celsius, to obtain 144,000 J or 144 kJ. So the total energy needed to heat both the water and the pan is 814 kJ. Note how much more energy is needed to heat the water than the pan. Look through the list of specific heat capacities on page 125 to find other metals from which you could make a pan that would need less energy to heat it. The high specific heat capacity of water makes it a good material to use, for example, in cooling an automobile engine by circulating the water through the engine where the water is heated and then through the radiator where flowing air can cool the water.
What is the danger of short circuits in a home?
As described above, if there is only a tiny amount of resistance in a circuit, the current is very large and the wires get extremely hot. If, for example, the insulation on the wires in an appliance fails and the wires touch each other, the resistance drops and current rises. The wires, including those in the walls, can get hot enough to cause a fire. Household circuits are protected by fuses or circuit breakers. They are designed to open when current exceeds a predetermined limit. With the circuit now open, current stops and the wires will cool.
What is friction force?
A force due to an interaction between an object and the surface on which it rests. Always in the direction opposite the motion. Depends on the force pushing the surfaces together. In most cases is larger if the surface is rougher. Generally doesn't increase if the speed of motion increases. Friction equals Nn.
What is the stainless steel?
A non-rusting alloy of iron and chromium and nickel. May also contain silicon, molybdenum, and magnesium.
What would happen if you had a multitude of pinholes at the location of the lens?
The reproductions from all the pinholes would be at the same location. And many more rays from the object would end up at the same place on the image. The image would be much brighter. So, you can model the formation of an image by a lens as a collection of reproductions of pinholes. The larger the lens, the brighter the image.
What is the inner ear?
Consists of the cochlea and 3 semicircular canals that sense the Bode's motions and give rise to a sense of balance.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
How can a machine with a mechanical advantage less than or equal to 1 be useful?
If a simple machine has a mechanical advantage less than 1, then you exert a larger force on it than it puts on whatever object it contacts. The output force is less than the input force.
How did fiber optics originate?
The idea that light could travel through glass strands originated as far back as the 1840s. When physicists Daniel Colodon and Jacques Bobinet, 1794 to 1872, demonstrated that light could travel through bending water jets in fountains. The first person to display an image through a bundle of optical fibers was a medical student in Germany by the name of Heinrich Lamm, who, in 1930, used a bundle of fibers to project the image of a light bulb. In his research, Lamm ultimately used optical fibers to observe and probe areas of the human body without making large incisions. From that point on, serious research in optical fibers ensued, expanding later with the development of the laser. Fiber optics are glass fibers that transmit laser light that can contain digital information more quickly and efficiently than metal cables.
What is the weak nuclear force?
Cause of beta decay. Weaker than strong nuclear force. Shown to be an aspect of the electroweak force carried by the massive W+, W-, and Z degree particles.
What is the difference between pitch and frequency?
Frequency, like sound intensity, is a physical property. Pitch, like loudness, is a description of how the ear and brain interpret the sound. Pitch is primarily dependent on frequency, but depends somewhat on loudness. Timbre, and envelope, which will be discussed below. Humans hear pitch in terms of the ratio of two tones. The ear perceives two notes to be equally spaced if they are related by a multiplicative factor. For example, the frequency of corresponding notes of adjacent octaves differ by a factor of 2 notes. In common chords are related by ratios of 3:2, 4:3, 5:4, etc. In the same way, the perceived difference in pitch between 100 Hz and 150 Hz is the same as between 1000 Hz and 1500 Hz.
What is the nuclear model?
Extremely small positively charged particle, the nucleus, surrounded by electrons.
Who discovered what makes an object hot?
Benjamin Thompson, Count Rumford, 1753 to 1814, who was born in the Massachusetts Bay Colony, but did most of his scientific work in the Kingdom of Bavaria, now part of Germany, deserves most of the credit. Before his experiments, most scientists thought that hot objects contained an invisible fluid called caloric. Experiments done before Rumford showed that when you heated an object it didn't gain weight. So caloric must be weightless as well as invisible. This result made many scientists suspicious of the caloric explanation, or theory. In 1789 Rumford drilled holes in bronze cannons through which a cannonball would be shot. He found that both the cannon and the metal chips that resulted from the drilling became hot. He determined the amount of water that could be raised to the boiling point by both the cannon bodies and the chips and showed that the caloric theory did not agree with his results. He finally concluded that in hot objects the particles that made up the material moved faster than they moved in cold objects. Using our present terminology, they had more kinetic energy. In their motion they vibrate back and forth, they do not move together like a thrown ball.
What is a fluid?
A liquid or gas that can flow and assume the shape of its container.
What is physical optics?
Division of optics that depends on the wave nature of light, polarization, diffraction, interference, and the spectral analysis of light waves.
What is the difference between a kilowatt and a kilowatt hour?
A kilowatt, 1000 watts, is the unit used to describe the power. The rate at which the energy is being converted. Energy is the power multiplied by the time it is used, in this case hours. Therefore a kilowatt hour, the product of power and time, is a unit of energy. The utility company charges you for the number of kilowatt hours of electricity you use in a month. For example, a 100-watt light bulb uses 100 watts, or 0.1 kilowatt, of power. If that light bulb were left on for an entire month, the energy that the bulb consumed would be 0.1 kilowatts x 24 hours/days x 30 days/month, which equals 72 kilowatt hours/month. If the energy cost is 12 cents per kilowatt hour, the bill for that one light bulb would be $8.64 per month. Replacing the 100-watt incandescent lamp with a 23-watt compact fluorescent lamp that is equally bright would cost only $1.98 per month. An LED lamp equally bright has a power rating of only 13 watts, and therefore would cost $1.12 to light.